So we all know what happened to Southwest 737 MAX on its route to Auckland from Phoenix. At about 35,000 feet, there was a sudden wagging of the tail, and this phenomena we call it the Dutch roll. So in this video, I'm gonna explain number 1, what is a Dutch roll, number 2, what causes a Dutch roll, number 3, how we as an aviation industry manage Dutch rolls, and number 4 is, should people be afraid of flying? Let's see. So what is a Dutch roll? A Dutch roll occurs when the lateral stability is greater than the directional stability. What does this mean? Well, let me explain you two terms going forth so it's easier to understand. So this movement, we call it roll movement. Roll to the left or roll to the right. And this movement, we call it yaw movement. That's yaw to the left, yaw to the right. So in layman's term, a Dutch roll is when the yawing happens to on one side of the aircraft and rolling happens at the other side of the aircraft, and this will give a movement like this. Well, let me break it down into few steps. So let's take a scenario. What causes a Dutch roll? A Dutch roll happens when there's turbulence. And what is turbulence? Turbulence is the disruption of smooth flowing air. So whenever the aircraft travels through a turbulent air, it gets a bit bumpy. But this is normal. Talking about turbulence, we can categorize them into two main types. That is severe turbulence and mild turbulence. Mild turbulence, it's normal in a flight. So severe turbulence can be due to many reasons. It can be mechanical turbulence or convectional turbulence. Now mechanical turbulence further divides into different parts, but I'm not going to go deep into them. And convectional turbulence happen due to temperature differences. So now that we know what a turbulence is, let's take a scenario to understand what a Dutch roll and how it occurs. So an aircraft is moving in a straight line. Let's just say a mechanical turbulence occurs. One part of mechanical turbulence is CAT turbulence or clear air turbulence. So a CAT turbulence might come as shear forces, like shear wind forces. So let's just say now there's a shear wind force coming from this end and it hits this wing and it's dropped this wing. Now it has rolled down. So when a wing drop or when the aircraft is in a roll, it can cause something called a side slip. A side slip is movement of the aircraft to the sideways relative to the oncoming air. So now when this happens, as you can see, there's a higher surface area exposed to the air coming. So when compared to this left hand side, so when more air comes from this right hand side, it causes lift of the right wing. What is a lift? Well, according to Bernoulli's theorem, when the air passes over and below the aerofoil, high pressure will get built up below the aerofoil and low pressure above the aerofoil. I mean, this aerofoil is a cross section of a wing. So high pressure below, low pressure above will cause us a positive upward force because of the pressure. So that's when the lift happens. Now the aircraft is like this and there's high pressure building below this wing, creating it to lift up. And with the lift, there is something that increases, and that is drag. Drag is the resistance force opposes the movement of the aircraft. If the aircraft is moving forward, drag try to push it back. Easy. So now when more lift is created here, high drag is created here, so the aircraft turns like this and the nose will go towards the right. When the nose goes towards the right, the aircraft is in a position like this. Now what happened is there's more exposure to the this side of the vertical stabilizer. As you can see, the air will come from this side of the vertical stabilizer compared to this. So this will have a higher angle of attack. So what this does is it actually pushes the aircraft this way. Now if the lateral stability is strong and it overshoots, this process will continue in a cycle and not that way. So this will happen to this aircraft. So what do we do as an industry to manage dust rolls? Well, modern aircrafts are equipped with something called a yaw damper. A yaw damper is nothing but an autopilot system to manage any deviation. Let's just say an aircraft is flying level and straight, and some turbulence makes it behave differently. Let's just say it deviates from its flight path. Now what the yaw damper does is it does this calculation, how much is the deviation and how much do we need to correct it, and by knowing this, the correction value, it corrects the aircraft to move back in its pre-described path. So that's what a yaw damper does, and yaw dampers can identify any dust roll before it happening and start correcting. Secondly, pilots are well trained to handle situations like this. Obviously we have had dust rolls in the past, so we have taken those scenarios and made them training modules so pilots can train in simulations and they can learn how to overcome this so-called dust rolls. And finally, aeronautical engineers keep these phenomena in mind when they design aircraft. We design the aircraft to balance out its lateral stability and directional stability. We design wings so that they are better equipped to handle situations like this, and we take care of the integrity of the whole structure so these forces might not harm anyone inside the aircraft. So finally, should people be afraid of flying? In my point of view, air transportation is still the safest mode of transportation compared to other modes of transportation. And another factor that will enforce my previous comment is pilots, cabin crew, maintenance staff, and also anyone who supports and manages the aircraft are well trained. Especially pilots, they train intensively in simulators for hours to come out of situations like this because we know it had happened in the past. And cabin crew is not only there to serve your steak and wine, they are well trained to handle fire situations, in cabin fight situations, as well as they are well trained to handle ditching situations. So they are your first point of call in an emergency. And obviously safety is the topmost priority when it comes to aviation. We do not compromise safety at any cost, and safety is not only the responsibility of pilots, cabin crew and engineers, and passengers do have a part to play in it. One of my past experience flying is I see passengers come into their seat and fasten the seat belts, and when the aircraft takes off and comes to a cruising altitude, they take off the seat belt. I do understand why, because there's a light on the cabin which says okay, now you are safe to take off the seat belts. But me personally, I never take off my seatbelt except I have to run to the loo. So when I'm sleeping or when I'm going to sleep, what I do is I loosen the seatbelt so it still keep me safe while flying, because I know there can be turbulence and it can get bumpy sometimes. So what I do is I do keep my seatbelt on at all times. And finally, modern aircrafts are equipped with different various sensors and components to detect any abnormalities happening to aircraft. In conclusion, no, I do not think you should be afraid of flying. Do your bit, keep your seatbelt fastened, listen to the cabin crew, and also read the instructions in front of your seat, and sit back, relax and enjoy your flight. I'll see you next week.